Hello guys, we are back with another GFG problem. Today we are going to solve the problem on the topic of tree. So let's see the question. So today's question is lowest common ancestor in a binary tree. So you have a given a binary tree with all unique values and two nodes value n1 and n2. The task is to find the lowest common ancestor of the given two nodes. We may assume that either both of n and n2 are present in the tree or none of them are present. Okay, if there okay, let's understand the question through the example. So you have a given a two nodes value and uh, and tree, and you have to find out, is it possible any lowest common ancestor of having this node and this node. So so in that case, in this tree, is it 2 or 3 is present? Yeah, it's present. So it must have some, it have ancestor, common ancestor. So we have to find out our lowest common ancestor. So in that case, the lowest common ancestor is 1. So let's see another example to understand more clearly. So you have given one node value is 3, another node value is 4, and you have to find out lowest common ancestor, and you have given this tree. So first and foremost, we have to check, is it 3 and 4 are present or not. If both are present, then we are going to find out the lowest common ancestor in that case. Otherwise we are going to return -1. hmm? We are going to return -1. So 3 and 4 are present in this tree. So it means we have to check uh, who is the lowest common ancestor. 5 is also ancestor of both of them, but we have to find lowest common ancestor. So we come to the 2. 2 is the lowest common ancestor of both of them, because we can reach to 4 bypass from this 2. So that's why 2 is our common ancestor in that case, and is it low, and it's also lowest. So in case we are going to return this node. So that's the basic approach of mine. If both are not present, we going to return -1. In that case, return a node with a value of -1. Okay, so how can we approach for solving this problem? One thing I notice, one thing, both n1 and n2 must be present into this given tree. If it present, then I'm continue my uh, uh, continue my coding journey. Otherwise I'm going to return a node which having value -1. So what I say, let's make a vector. If it's present, let's think both n1 and n2 present. In that case, what I have to do, I have to find out the path from root to this n1 node, from root to this n2 node. Then what I do, I have to I have to I have to do one thing. I have to comparing both of them. If both are equal, I'll move one step ahead, and I have to again check. If both are again equal, I make the point, I shift the pointer one step and again check. If both are not equal, where it last time it common, that's not I'm going to return. So let's write the code, you can understand better. So I'll made it uh, I made it two node, two vectors. One is v1, another is v2, uh, v2 v1 containing the root 2 node n1 uh, nodes, corresponding nodes, it means a path, and v2 containing from root to n2 path. Okay, and I have called my, I made it a solve function. In this solve function, it take the parameter root. It actually does, it create the path. If path is possible, it going to create it. If it not possible, it going to return null. So root, uh, and let's make n1 and this v1. Same thing I am doing for n2. Yeah, if it possible, it makes the things. If it not possible, it not doing anything. And after that, what I have to check, if my v1 dot size is equal to 0, or my v2 dot size equal to 0. In that case, what I'm going to do, in that case I have to return null, or maybe return -1. Okay, if not the case, I have to return -1. If anyone is empty, it indicates my n1 or n2 may be not found in this root tree. So if possible, if both having some value, it means it have some common thing. So I have to find last common value. For finding the last common value, I'll make it, I'll iterate my pointer, I pointer, from 0 to I v1 dot size, and this I v2 dot size I plus plus. If my v1 I not equal to, sorry, if v1 I not equal to v2 I am going to return, I am going to break my loop in that case, and I have to return v1 I minus 1 in that case. So if both are unequal, it means its previous one it's common, but current one is not common in that case. So I have to return this. Okay, that's my basic addition. I have only one, I have one step. I have to complete my solve function for completing our whole code. So I'm going to complete it my uh, solve stub function, and I'll make it as a bool time, because it telling us, it will telling us, is it possible, is it is it possible to make creating a root or not. Is it possible to find this n1 n2 in this given given tree. So that's why I just made it. So node root, it takes key as well as my vector, which is node star and v. If root equal to null, in that case I have to return 0, because it's not possible to find out the my key. If And my first duty, I assume, yes, it's possible to is it possible, it's possible to find out the node. So in that case I have to push pushing into my given in the vector. So I'll just push it the root into my vector. If root data is equal to key, I have to stop my uh, searching and looking, and I have to return 1 from here. Otherwise I have to do the job. I have to again I have to again searching and looking for the uh, n1 for the keys. So for that I'll just made is uh, I'm looking in the left side, uh, as well as if it's present in the left side I have to return 1. I'll just copy it again, and if it possible to find out into the right, I'm just going to look it at the right side too. If both sides are not able to find out, what we are going to do in that case, mm, we just remove the element from which we are pushing into the vector, because it's not possible to find out through this path, and I have to return false in that case. Yeah, that's it. So let's run this code, guys, and it give us compiler. Yeah, n1, let's make it empty, and ready for evolution. I guess I have a low net speed. Yeah, let's submit our code, guys. And it's kind of work, and it's submitted. So if you have any doubt, let me know in the comment section. I resolve your doubt as soon as possible. And thank you, guys.